Here's integrated 3. It's one of the closure problems. CL11-114B has a typo, at least in my book. It says 4x squared minus 3x squared minus 10x. They meant 4x cubed. So maybe that was the whole problem, but I'm going to go ahead and do this problem. I did it in our Zoom meeting, but I'll do it again here, or maybe it was one just like it. I think I did this one in our Zoom meeting. So this up here is a difference of cubes. And so you can do polynomial division on this if you don't know this formula, but since I know that there's a formula that exists that helps me factor a difference of cubes, I'm just going to use the factor pattern. It says if I have something that's a perfect cube and something else that's a perfect cube, because 8 is 2 cubed. So really I have like x cubed minus 2 cubed. So I could say, say this is A and B. Like I could say x is A and 2 is B. Okay, so what I'm going to do is I'm going to rewrite this formula right here, and I'm going to fill in the blanks with my A's and B's. I'm just plugging the numbers in. All right, what's it got? A couple plus signs. So I'm saying that A is, because I'm looking at this perfect cube, I'm saying A in our case is x, and B in our case, because 2 times 2 is 4 times 2 is 8, B is going to be 2. So this says A minus B, so that's going to be x minus 2. And then it wants A squared. So remember, that's x, so that's going to be x squared. And then it wants A times B, so that'll be 2 times x, 2x. And then it wants B squared, so that's, well, 2 times 2, that's 4. Okay? And then on the bottom, I think this one confuses people because, because there was a typo, but also you can factor out an x. This will be 4x squared minus 3x minus 10. And if I wanted to check, I could go x times 4x squared, doesn't it make 4x cubed? And x times negative 3x makes that, and x times negative x. Okay, so now I have some work to do because I have to do some more factoring to simplify this. So to factor this one on top, this one I don't have to do the little area model box if I don't want to, because it doesn't have a coefficient that is other than 1 here. So it's going to multiply to make 4 and add to make 2. So, let's see. Oh, well, okay, so this is not going to factor, is it? And that's okay. I mean, I could get out the quadratic formula and do something to it, but there's no two numbers that multiply to make 4. 2 times 2, that'll never work, and 4 times 1, that'll never work. So we're just going to leave that alone. Let's at least try to factor this down here, though, and see if we can get, maybe this one will factor, and we'll be able to cancel out the x minus 2 if we're lucky. So let's see what happens when we try to factor this. I'm going to have 4 times negative 10. That's what it has to multiply to. And then negative 3 is what it has to add to. And I know 8 times 5 is 40, so I think that works. And I got to put that in the area model box because I've got the 4 in front of my x squared. So, and then I got the negative 10 down here, and then I got negative 8x and 5x. So I'm splitting that negative 3x into negative 8x plus 5x. And then I'm just going to use my area model. So I think I'm going to do 4x here and x, because that times that has to equal that. Does that work? Oh, I got my x minus 2. So now I'm going to just rewrite the whole thing. So I'm a little sad that this one didn't factor, but we got the x minus 2 factoring, so that's nice. So those two can cancel out, and then I'm just left with this. And if I want to, I can say this is 4x squared plus 5x. Let's see what your book says. Your book just leaves it like this. And yes, there was a typo because your book said it was 4x squared and they wanted 4x cubed.